All right, welcome back to the Explainer. So, if you're gearing up for the Cambridge IGCSE Math 0580 exam, you are exactly where you need to be. Today, we're taking on a topic that, let's be honest, kind of terrifies even the best math students, algebraic fractions. But here's the secret, okay? They're literally just simple, everyday numerical rules dressed up in a slightly more intimidating algebraic outfit. That's it. By the end of this Explainer, we're going to strip away all that complexity and you'll be tackling these expressions with total confidence. Here's our quick roadmap for today. First, navigating algebraic fractions. Then, simplifying by factoring first. Third, finding common denominators. Fourth, adding and subtracting. And finally, avoiding common errors. Let's jump right in. Section 1, navigating algebraic fractions. Okay, take a look at this side-by-side comparison. On the left, we've got simplifying regular numerical fractions. How do we actually do that? Well, you just cancel the common factors of the numerator and the denominator, right? Now, look at the right side, simplifying algebraic fractions. The rule, it is exactly the same. Cancel common factors of the numerator and denominator. I really want to build this bridge for you right out of the gate. Think about it. If you know how to simplify 2/4 into 1/2, you already possess the underlying logic you need for these complex algebraic fractions. The fundamental laws of math simply do not change just because we threw a few letters into the mix. But to actually apply those rules correctly, we need to be crystal clear on our terminology. What actually is a factor in algebra? Well, it can be an individual number, a single letter, or even an entire expression stuffed inside brackets, as long as they multiply together to make up the top or bottom of that fraction. The absolute key here is that a factor is always part of a multiplication relationship. And here's the golden rule. Only factors can be canceled out. Seriously, this definition is your new best friend. Keep it front and center, because mixing up a factor with a term is without a doubt the #1 reason students drop marks later on. Moving on to Section 2, simplifying factor first. Now, what's really interesting about this slide is the trap so many people fall into. Check out example 21.2, pulled straight from the source text. We need to simplify x squared plus x all over x squared minus 2x minus 3. Okay, looking at it right now, it cannot be canceled. No way. You absolutely cannot just cross out the x squareds on the top and the bottom. That's a massive red flag. First, both the numerator and the denominator have to be factorized. So the top becomes x, bracket x plus 1. The bottom factors out into two brackets, x minus 3 and x plus 1. Now, and actually only now, we can clearly see that the bracketed expression x plus 1 is a factor of both the top and the bottom. So we go ahead and cancel that entire bracket, leaving us with a really clean, beautifully simplified x over x minus 3. I actually want to pause right here and really shine a spotlight on this note from the text. It says, errors often occur by canceling individual terms. Only factors, which can be individual numbers, letters, or brackets, can be canceled. I want you to imagine this flashing in bright neon lights when you're sitting in the exam hall. If you spot a plus or a minus sign tying an x to another number, that's a term. Do not touch it. Don't cross it out. You have to factorize it into a bracket first, turning it into a multiplier. Only then do you have the green light to cancel. All right, Section 3, finding common denominators. So, just like working with plain old numbers, you can't add or subtract algebraic fractions unless they're sitting on the exact same base. Here is our foolproof 3-step procedural method. Step 1, write all fractions with a common denominator. Step 2, multiply the numerators by whatever you used to match that new base. And step 3, add or subtract those numerators while keeping your common denominator exactly the same. It's like a steady, reliable rhythm, you know? Just stick to these steps, and I promise you won't get lost in the weeds. Let's move to Section 4, adding and subtracting, and see how this all builds together. Take a look at example 21.3 right here. We've got x plus 3 over 2 minus x minus 3 over 3. Okay, step 1, find that common denominator. For 2 and 3, well, that's obviously 6. Step 2 is where we carefully tweak those numerators. To turn our denominator of 2 into 6, we multiplied by 3, right? So we've got to multiply the entire top part, the x plus 3, by 3 as well. Same logic for the other side. Turning 3 into 6 means multiplying by 2, so we multiply its numerator, x minus 3, by 2. Notice how the text lays this out perfectly. 3 bracket x plus 3 minus 2 bracket x minus 3 all over 6. This really careful, highly structured setup is exactly what you need to be writing down on your exam paper. And you know, this perfectly sets us up for the next level. In example 21.4, we're subtracting 2 over x from 3 over x plus 1. Now, our denominators are algebraic expressions, not just plain numbers. But does the actual procedure change? Nope, not at all. The common denominator here is just those two original denominators multiplied right together. X times the bracket x plus 1. We adjust the numerators exactly like we did a minute ago. The 3 gets multiplied by x, the 2 gets multiplied by x plus 1. Then we carefully expand the brackets on the top, which gives us 3x minus 2x minus 2, and simplify that down to get x minus 2 all over x bracket x plus 1. The whole framework stays completely identical regardless of how crazy the letters get. Which brings us to Section 5, Avoiding Common Errors. All right, welcome to the danger zone. When you're adding and subtracting, the source text hits us with a massive warning. It explicitly says, do not miss out the first step. Most errors occur because of expanding the brackets wrongly. Remember that step in the last couple of examples where we wrote out the numerators with their multiplier sitting outside the brackets before we actually expanded them? Yeah, do not skip writing that line down. Trying to expand brackets in your head while juggling common denominators is exactly how a minus sign mysteriously vanishes and how easy marks get dropped. Just write it out. Protect your grade. So let's pull all of this together into your Golden Rules Study checklist. Whenever you're facing down algebraic fractions, lock these 3 absolutes in your mind. 1. Always factorize the numerator and the denominator first if you want to simplify. Put things into brackets. 2. Cancel only common factors. Never, ever, ever cancel individual terms separated by plus or minus signs. And 3, if you're adding or subtracting, you absolutely must write everything with a common denominator first, taking the time to carefully expand your numerators. And that brings us to the end of today's explainer. I want to leave you with a quick question to think about the next time you sit down to study. Will you navigate this algebraic minefield safely by writing out every single step? Or will you let the individual term trap cost you your next grade boundary? The logic is totally straightforward, the rules are clear, and now the execution is entirely in your hands. Thank you so much for tuning in. Keep practicing, stay sharp, and we'll see you in the next explainer.